This video is part 2 for increasing and decreasing functions using calculus. So we're going to move down to this. I'm going to keep this video really short. So instead of showing that the derivative of this function here is this other function over here, I'm just going to bump down to part B. Now, because we have this function here of f of x is a function divided by a function, what should come to mind is the quotient rule. If we do the quotient rule, we should be able to show that this function here is this function here. Now it says, hence find the interval where our function here is increasing and decreasing. So I'm going to find, I want to know where my stationary points are, so I'm going to make my slope 0. And then I'm going to solve for x. Now, my stationary points then are going to be at -1 and at 1. Because if this x here is -1, the -1 plus 1 is going to give me 0, and then 0 times -4 is 0, and 0 times this quantity here is 0. So I have 0 over some quantity. Now, if this x over here is 1, then 1 minus 1 is 0, and then 0 times this quantity is 0, 0 times -4 is 0, and I have 0 over some quantity, which is still going to be, it's going to give me 0. Now, I also need to consider the critical points, where my graph is going to, where I have vertical asymptote. Now I have vertical asymptotes when the denominator is 0. That I want to know the x values that would not be allowed on this graph because that would give me a denominator 0. So that's going to give me, in this case, my vertical asymptotes are going to be at 1 and -1, which is sort of because -1 squared is -1 times -1, which is a positive 1, and then I have 1 plus 1, which is going to give me 1. So it doesn't look to me. Can I get a 0 down here? It doesn't look like I can get 0 here. There is no vertical asymptote. There's no value I can plug in for x that will give me 0 here in the denominator. So there is no vertical asymptote. So let's go ahead and look at, I just want to know when the graph is increasing or decreasing. So we have some, let's go ahead and do our sign diagram at -1 and 1. Now I'm going to find some value on the left-hand side. We're just worried about, this is called a sign diagram. So I'm mostly concerned about whether I have a positive slope or a negative slope. So this is my slope equation. I want to know what the slope is at some number on the left-hand side of -1. Let's say, I don't know, -10. So if I plug in -4, well, that's always going to be negative. And if I plug in -10 here, then -10 plus 1 is going to give me -9. That's a negative. And then if I plug in -10 here, -10 minus 1 is going to give me a negative number. And then if I plug in a negative down my -10 here, then because I square it and then I square it again, it's always going to be positive. So it's always going to be over a positive number. But in the numerator, a negative times a negative times a negative is a negative. So my slope is going to be negative. The slope is going to be negative on this side over here. But what happens after -1? Well, let's try 0. Let's plug in the 0 here. If I plug in 0 here, I get 0 plus 1. I still have the -4, right? So I have -4. And if I plug in 0 here, 0 plus 1 is going to give me, it'll give me 1, which is positive. And then plug in 0 here, 0 minus 1, that gives me a negative. And that's over 0. 0 squared, which is 0, plus 1, which is 1. And then 1 squared is 1, so all of that is positive. So I want to know what a negative times a positive times a negative is. That's going to give me a positive. So my graph, it looks like it's moving back up here. So this is going to be a minimum point. And then what happens after 1? Well, let's try, I don't know, how about 10? Let's try 10. So I have this -4 hanging out here times this 10 plus 1, that's 11, that's positive. And then we take the 10 here, 10 minus 1 is going to give me a positive number. And then all over a positive, and a negative times a positive, that's a negative, and I have a negative over a positive, that's a negative. So it looks like at that point we have a local maximum point. So we can see if we're trying to find the points that are increasing and decreasing. Well, we are increasing then increasing from -1 all the way to 1. And then we are decreasing from -infinity to -1, and then from 1 to infinity. So we could actually throw this in our calculator if we want to and examine whether this is actually what is happening. So I have y equals, and then I have, this is going to be some irrational number, so it's going to be a rational function, -4, times x plus 1 times x minus 1, all over x squared plus 1 squared. So we do have our stationary points are, I think, did I do that right? I actually just typed in, I typed in our slope equation. So this is 4x divided by x squared plus 1. So we have our stationary points at here and here. So we see that the graph is decreasing all the way to -1. It decreases from 1 to infinity, and then we increase from -1 to 1. Let's do another one. So I'm going to assume that this is true, but I would encourage you to get the practice to use the quotient rule to show that this function here is equal to the derivative here. And I want to find where the graph is increasing and decreasing. So I'm going to use my slope equation. I'm going to make this 0, and so that I can find out when my slope is, well, I'm trying to find my stationary points. So one of my stationary points is going to be at -1, because -1 plus 1 is going to give me 0, and 0 times -4 is going to give me 0. I have 0 over some quantity, which is still 0. So, and then we also, this is a stationary point. And I also want to find my critical points. My critical point is when at a vertical asymptote at 1, in this case, when x equals 1, which is not allowed on the graph at all. So I have 1 minus 1, which is 0. So let's do a sign diagram at -1 and 1. Let's find some values below -1. How about, again, let's do some like -10. So I have -4 times -10 plus 1. That's going to give me a negative number. And that's all going to be over -1 minus 1. It's going to give me a negative number. And a negative number times a negative number times a negative number is a negative number. So I have a negative times a negative divided by a negative. That is a negative. So my graph is going to be, decreasing to this point. And then let's use, 0. Let's plug in 0. So I have this -4. And then times 0 plus 1, that's positive. So I have a positive number. And then 0 minus 1 gives me -1. And then -1 times -1 times -1 is a negative. So I have a negative. So a negative times a positive is negative. Negative divided by a negative is a positive. So I have a positive there. So my graph at this point is going to graph upward at this point. Some number after 1, how about 10? So I have that -4. And then times 10 plus 1, that's positive. And then 10 minus 1, that's positive. And a positive number times a positive number times a positive number is a positive number. So I have a negative times a positive divided by a positive. That's going to give me a negative. So I have a negative on the side. So the graph is going to go down at that point. So the graph then is going to be, I should also indicate, I really need to keep track of this, because that does matter. So I have a vertical asymptote here. So that means that, this is not a maximum point. The graph is going to look something like this. It's going to go down, it's going to go back up, and then here the graph goes up. We have some vertical asymptote here. The graph goes up, which means it's going to converge on that asymptote, and then we have a negative slope, so it's going to converge going downward like this. So it's going to look something like that. So if we're just looking at the increasing and decreasing, the graph is increasing from, what was that, -1? From -1 to 1. 1 is not included because that's not included anywhere on the graph. It's not allowed, 1 minus 1. And -1 is included. That's just a stationary point. And then the graph is decreasing. Decreasing from -infinity all the way to -1. Parentheses. And then from 1 to decreasing from 1 to infinity. All right, let's look at another one. It says I have this function here. So, let's see, is that, it looks to me like, yeah, we could just do it. So let's find out. So I'm assuming that this is true. And you should again get practice. This is using the quotient rule to take this function to this derivative. I want to find my stationary points when my slope is 0. And so my stationary points are going to be at x equals -1 and 3. And then we should also keep track of our vertical asymptote, and that's going to be at 1. Let's see, let's check if that's 1. 1 minus 1 gives me 0, 0 squared is 0. So we have at x equals 1. That is a vertical asymptote. So let's look at, let's do our sign diagram at -1, 1, and 3. And let's see, let's plug in some value. Let's look at the slope on the left-hand side of -1. So how about -10? So I have this negative times -10, that's a negative number. And -10, that gives me another negative number. Over a -10, -10 minus 1 is going to give me -11 squared is a positive, so that's divided by a positive. So I have a negative times a negative times a negative, which is a negative, divided by a positive, which is a negative. On this side over here, we're going to take some number. How about 0? I'm going to plug in 0, so I have this negative. 0 plus 1 is positive. 0 minus 3, that's negative. And then 0 minus 1 gives me -1, and squared, that's going to be positive. So I have a negative times a positive times a negative, that's a positive, divided by a positive, that is a positive. So our graph is going to go, the graph is negative here to this point, and then becomes positive. So this is a minimum point, local minimum, and then this is and it looks like this is an asymptote here, so we're going to just converge. We just keep on going up and converging on that asymptote here. Let's find some value. I want to know what the slope is at, say, 2. So I have this negative, and if I plug in 2, 2 plus 1, that's positive. I'm going to plug in 2, 2 minus 3, that's going to give me a negative. Over a positive, 2 minus 1 is 1, squared is positive. And we have a negative times a positive times a negative, that's a positive. Positive divided by a positive is a positive, so this is a positive. So our graph is going to converge, it's going to converge this way because it has to be positive. We read a graph from left to right, that's positive, the graph goes up. So let's take the 3, some number above 3, how about, I don't know, 5. We'll plug in, we still have this negative, times 5 plus 1, that's going to be positive. Take the 5 minus 3, that's going to be positive. All over, always, this will always be a positive unless the x is going to be 1. And so I have a negative times a positive, that's a negative, divided by a positive is a negative. So we have a negative. It looks like we have a local minimum point there. So our graph is going to, a local maximum, I apologize, it's a local maximum. So our graph is going to be increasing from -1 all the way to 1. 1's not, it's an asymptote, a vertical asymptote. -1 is included, and then we also increase from 1 not included all the way to 3. And then we decrease from -infinity to -1. And then we also decrease from 3 to infinity. So let's go ahead and throw this into our calculator and see what this looks like. So y equals, it's rational, so I have -x squared plus 4x minus 7 all over x minus 1. So we said that we were decreasing from infinity all the way to -1, and then we're also decreasing from 3 to infinity, and then we said we were increasing from -1 to 1 not included because we have a vertical asymptote at x equals 1. So we converge on 1, x equals 1, and then from -1 all the way to that maximum point as well. So we didn't know exactly what the graph looked like, but we knew we knew where the graph was increasing and decreasing. So anything else that's interesting? Find the interval where f of x is increasing, decreasing. It's the same concept. Just take the derivative. Once you have the derivative, then we set the derivative to 0 to find our stationary points, and then do a sign diagram. Hope this video was helpful, and have a wonderful day.